Hi, my name is Shannon Olgin, and I'm recording this for the fall 2022 Anatomy and Functions of the Eye class. And today we are going to look at 18 of the systems that comprise our eye. First, we're going to look at the outer protective layer of the eye. It is comprised of the sclera, and the sclera is the outermost layer. It is made up of a tough, white, fibrous film whose main purpose is to protect the eye. And it's covered by a clear membrane called the conjunctiva that also lines the inner portion of the eyelids. Then we see the cornea. The cornea is the front transparent part of the eye whose bulging curvature, see the curve, provides the focal strength of the eye. Hey, do you happen to know why the optometrist decided to go into real estate? It's because he wanted to cornea the market. Now we're going to move on and look at the part of the eye that provides more of the nutrition. This is the middle coat of the eyeball, and we're going to look at the choroid first, and it consists primarily of blood vessels, and their purpose to supply the blood flow and the nutrition to the outer layer of the retina. Then we have the ciliary body. The ciliary body is made up of 4 muscles, so we can also call it the ciliary muscles. And these muscles control the focus of the eye. They do this by changing the shape of the lens, which is the resilient, transparent structure of the eye that focuses light by changing its curvature. The lens and the ciliary muscles are connected by these long, thin fingers known as the suspensory ligaments. So they're right in here and in here. The lens gets fatter when we focus it near to converge the rays of light to the closer working distance. And then the anterior chamber is right here, and it's kind of in between the cornea and the lens, and it is filled with aqueous humor, and that's a watery fluid that provides some of the nutrition to the surrounding areas. The collection canal that delivers or transports the aqueous humor to the venous system of the body is known as the canal of Shannon. Directly behind the lens, you're going to find a clear jelly-like substance that fills the posterior segment of the eye, and it's known as the vitreous humor. All within here, we're going to see that jelly-like substance. In front of the lens, we see the colored portion of the eye known as the iris. So right here is the iris, and this is where you see that colored portion. The iris controls the amount of light that enters the eye by enlarging and minimizing the size of the pupil. And the pupil is a system, but it's also mainly a hole. It is the black hole in the center of the iris that allows the light to pass through. As the light passes through the pupil, it arrives at our next structure, the retina. So the light has come through here, and it's going to go all the way back to our retina. And the retina is the inner lining of the back chamber of the eye. It consists of 2 layers, a pigmented outer layer, and then a neural inner layer. The neural layer of the retina contains the photoreceptors, both the rods and the cones, and they receive light rays that enter through the pupil, and they convert these into electrical impulses. The macula, which is right here, is a small, thinned out area of the retina that consists almost exclusively of the photoreceptors cells, which provide the high visual acuity. And the fovea centralis is the central portion of the macula that has the highest concentration of the cones. And the ora serrata is the area of the inner eye where the retina ends and the choroid layer of the eye can be seen. See, it's in that area. The electrical impulses in the retina are relayed to the brain via the optic nerve, which is right here. The optic nerve is the bundle of fingers that carry vision-related impulses from the retina to the brain. In the head of the optic nerve, where the ganglion cell axons exit the eye, are known as the optic disc. And this is also known as the blind spot of the eye because there's no photoreceptors at the optic disc, which causes an anatomical blind spot of the eye. So those are 18 different areas of the eye. So we have this front portion, and then we have the fluid in the middle, and then we have all these receptors that help our brain turn the light into images. So it's very important that every one of these systems work in order to take these signals to the brain, and then for the brain to properly be able to translate them.